Data discretization is an important concept in data preprocessing. It's the process of transforming continuous data into discrete categories or intervals, which reduces the complexity of continuous features while preserving the essential patterns and relationships in the data. The goal of data discretization is to simplify data representation and improve model interpretability. If you remember our earlier discussions, you might have noticed that data discretization and data binning are very similar. In fact, they're essentially identical in some aspects. Let's look at an example. Imagine we have a dataset where different values represent different ages. Using data discretization, we can segment customers based on their age. First, we can apply the equal width discretization method by dividing the age range into 3 equally sized intervals. Then, we simply iterate through the original dataset to assign each data point to the appropriate interval. Alternatively, we can use custom discretization, where we segment age based on domain knowledge. Compared to the equal width method, custom discretization might be more appropriate in this example because we want to segment customers by age for targeted marketing messages. People in similar age groups likely have similar needs, so a tailored marketing strategy would be more effective. Through this example, I hope you can see how similar data discretization is to data binning. Both techniques transform continuous data into discrete categories or intervals. But the motivation for data binning and data discretization is different. Data binning is primarily used to simplify handling continuous data or to uncover patterns in data distribution. Its goal is to smooth out the data and reduce the influence of noise, and during this process, it doesn't rely on the dataset's labels, making it an unsupervised technique. In contrast, data discretization is mainly used in scenarios where we need to transform data into discrete features, such as for classification tasks. Because of that, data discretization relies heavily on class and label information to develop effective strategies, which means it falls under the umbrella of supervised learning. Finally, let's briefly review the pros and cons of data discretization. Since data discretization and data binning use almost identical methods and algorithms, their advantages and disadvantages are largely the same. By transforming a continuous dataset into a discrete one, we can apply advanced machine learning algorithms more effectively, and smoothing the data helps reduce the negative impact of noise. On the downside, while this process can mitigate noise, it might also suppress some data that would be useful for revealing the overall trend. Additionally, if the chosen method relies too heavily on domain knowledge and subjective assumptions, it can introduce extra bias into the dataset.